Hello, everyone. Today we are starting a very interesting and practical topic, that is probability. Before we dive into formulas, let's first understand the key ones in our topic title, which is Basic Probability Rules Explained Simply. So the key ones are basic, probability, and the rules. Because once you understand these ones, everything else will start to make sense. So the first step is understanding the key ones. So before we begin, let us explain the key ones. And the first one is, since we are running the basic probability rules, we are going to start with the word basic. And we start with the meaning. Basic simply means simple or foundation. It's what you learn first before going deeper. Basic means simple foundation or beginner level. The things you must understand first before moving to harder ideas, or to more difficult ideas for that matter. In class terms, for example, before you run to walk. Like learning how to count before doing multiplication. Before you multiply, you run to add. In this topic, basic means we are running the main ideas that all other probability topics will build on. So, basic probability rules means the simple starting rules that help us understand chance. We are not doing anything difficult today, just understanding the starting blocks of probability. The next key word is probability, because our topic is basic probability rules, and we have already dealt with the word basic. So, probability means how likely something is to happen. It tells us whether an event is certain, likely, unlikely, or impossible. Simple examples. The sun will rise tomorrow. We are certain that the sun will rise tomorrow, and the probability is equal to 1. Tossing a coin and getting heads. Possible, but not sure. Probability is equal to 1/2. A cow laying eggs. Impossible. Probability equals 0. In short, probability is a number between 0 and 1 that measures chance. So, 0, it will never be 0. That is, it's less than or equal to probability of an event is less than or equal to 1. Always. All right? So, probability lies between 0 and 1. Think of probability as the language of chance. It tells us how sure or unsure we are about something happening. We extend the keyword probability is our second one in basic probability rules. And we say probability is a big one, but it simply means how likely something is to happen. It's the measure of chance. Let's think about it. So I've decided to do this deliberately because I wanted to bring this tabulation below here. So situation, what might happen? Probability idea. So we have already mentioned this. The sun will rise tomorrow. What might happen? Definitely yes. Probability idea, certain, 1. Tossing a coin and getting ahead. What might happen? Maybe yes, maybe no. Probability idea, have a chance. Because there are 2 chances. It is either head or tail. A cow laying eggs. What might happen? Never. It cannot happen. So, probability idea, impossible. 0. So, probability is a number between 0 and 1, where 0 means impossible, 1 means certain, and the numbers in between show how likely something is to happen. Probability is the language of chance. Probability is the language of chance. It tells us how sure or unsure we are about an event. Remember, English is not our language, so there was a problem with the word chance. Let's now come to the third word. Remember, the topic, again, it remind you, is basic probability rules. So what is a rule? A rule is a guideline or mathematical law that helps us work out problems the correct way, or simply a guideline that helps us do things correctly. In real life, just as traffic rules guide drivers, probability rules guide us when we calculate chances. Example, there is a rule that says when 2 events cannot happen together, we add their probabilities. That's one of the rules we will learn. In mathematics, rules make sure we all get the same correct answer, not just guesses. Rules are what make probability fair and predictable. They stop us from guessing blindly. So we are through with the definition of our topic, basic probability rules. We have defined the word basic, we have defined the word probability, and we have defined the word rule. So, when we say basic probability rules, we mean the simple mathematical laws that tell us how to calculate chances correctly. Now that we understand what the ones basic probability and the rule mean, let's combine them. Let's explore the 6 main rules one by one with clear examples after each. We are going to learn the basic probability rules, the simple guidelines that help us calculate the chance of something happening. Rule number 1, the probability of an event. This is given by PE, where P stands for probability and E event, and it is equal to number of favorable outcomes you divide by the total number of possible outcomes. Explanation. Probability is not just a fraction comparing what you want to happen with all possible things that would happen. I beg your pardon. Probability is just a fraction comparing what you want to happen with all possible things that would happen. Example, you toss a die. What is the probability of getting a 4? Total possible outcomes are 6. That is 1, 2, 3, 4, 5, 6. Favorable outcome is 1, the number 4. So the probability of getting 4 is 1 out of 6 because we have only 1 4. Meaning you have 1 chance out of 6 to get a 4. It's possible, but not very likely. Rule number 2, probability of the sample space. P in brackets S equals 1. That is, P is probability and S is sample space. So the probability of sample space is 1. Explanation. The total of all possible outcome is always 1 because something must happen. Example, when you toss a coin, you either get a head or a tail. The probability of a head plus the probability of a tail is equal to a half plus a half, which is equal to 1. Meaning, the coin cannot disappear. One of the outcomes must occur. Rule number 3 is known as Complementary Rule. And this is probability of an event not happening. So the probability of an event not happening, that is A dash, equals 1 minus the probability of A. And A dash or A prime means not A. So we can put that statement again as the probability of not A happening is 1 minus the probability of A happening, where A prime or dash or not A denotes the complement of event A. Let's explain. If there is a chance of something happening, the rest of the chance is that it won't happen. For example, if the probability of rain is 0.3, that is, the probability of today raining is 0.3, then the probability of no rain is P no rain, which is 1 minus 0.3, which is 0.7. Meaning there is a 70% chance it will not rain today. Rule number 4, addition rule, which is known in probability circles as mutually exclusive events. We will discuss at the far end of the discussion about mutually exclusive events. There is something I would like you to know, but let's continue with this part first. So the probability of A or B equals the probability of A plus the probability of B. That is, if two events cannot happen together, we just add their probabilities. Example, rolling a die. Probability of getting a 2 or a 5. Remember, the sample space of the die is 1, 2, 3, 4, 5, 6. So probability of getting a 2 or a 5 is the probability of 2 plus the probability of 5, and each of them has got a probability of 1 out of 6 because we have only 1 2, plus 1 out of 6 because we have only 1 5. When you add them, you get 2 over 6, which simplifies to 1 over 3. Meaning you have 1/3 chance of getting either 2 or 5. Rule number 5, general addition rule. When events overlap or non-mutually exclusive events, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. That is what is common in A and B, you subtract. If two events can happen together, we subtract the overlap, so it's not counted twice. For example, in a class, 50% of students like mathematics. We represent them with A. 40% like biology, B, and 20% like both. So the probability of A or B is equal to 0.5 plus 0.4 minus 0.2, which is equal to 0.7, following the formula above there, meaning 70% of the students like at least one of the two subjects. And finally, rule number 6, which is known as the multiplication rule or independent events. Is given by the probability of A and B. So A and B are independent events, which is equal to the probability of A times the probability of B. And we say that if two things don't affect each other, multiply their chances. For example, toss 2 coins. What's the probability of getting both heads? P, both heads, is 1/2 times 1 times a half. Sorry, P both heads equals 1/2 times 1/2, because the probability of getting ahead is 1/2, and the answer becomes 1/4. Meaning there is 1 chance out of 4 to get 2 heads. That is head, tail, head, and tail. Okay? There is 1 chance out of 4 to get 2 heads. It is now time to review the main points, what we call recap. So we have rule, we have description, and we have example summary. So rule 1 is formula for any event, and it is given by PE. If it is for the sake of a die, PE is equal to 1/6 on a die. Rule number 2, all outcomes total to 1. So if you toss a coin, or coin toss, you have 1/2 plus 1/2, because you either get a head or a tail, and when you add the outcomes, the head gets 1/2, the tail gets a half, the total is 1. 3, opposite event or complement. The answer you get is you subtract the probability you have been given from 1, because the maximum probability is 1. So 1 minus 0.3, which is 0.7. Rule number 4, you add if events are separate. If they don't overlap, so that you have 1/6 plus 1/6. That is, if you are tossing a coin, you either get a 2, or you get a 1, or you get a 4, or you get a 3, but you cannot get 3 and 4 at the same time. And 4, you have the probability is 1/3. And number 5, subtract overlap. This is where you have events sharing some members, all right? And therefore you have like the probability 0.5 plus 0.4 minus 0.2 is 0.7. And number 6 finally are the independent events, where the occurrence of one does not affect the other. Like tossing a coin, you either have a head or a tail, so that the probability of a head is 1/2, and the one for the tail is 1/2, and the probability becomes 4. And you have to multiply. You multiply independent events. All right, let me wrap up. Probability is all about chance. These 6 rules are your toolbox. Once you know how to pick the right rule, every question becomes very simple and logical. Remember, always ask, what can happen? How many ways? Then use the right rule. Now, let us look at the first notations. Cap to you. Don't worry about the funny simple you. You simply means all. So whenever you see P, A, U, B, just read it as P, A, or B. You replace the U with B, the capital U. So when you write it as P, A, U, B, in brackets, or P, A, or B, you are talking about the same thing. The chance that either A or B or both happen. From now, here, we inform you that the symbol capital U is read as union. And it means A or B or both happen. So, if I read the first statement there is, so whenever you see P, A union B, bracket, just read it as P, A, or B. So whether you write it as P, A union B, or P, A, or B, you are talking about the same thing. The chance that either A or B or both happen. It comes from set theory, where union is the total correction of elements from both sets, including their overlap. So, P, or probability of event A or event B, is also the same as probability of A union the probability of event B. This is just a plain language version of the same idea. It says directly the probability that A or B or both happen. So, P, A union B is equal to P, A, or B. Both represent the same probability, the chance that at least one of the events A or B occurs. The second notation is inverted U, which looks like N. Don't worry about the funny symbol, the inverted N, the inverted U or N. It means and. So whenever you see P, A, inverted U, B, or you can call it A, N, B, just read it as P, A, and B. So, whether you write it as P, A, inverted U, B, or P, A, and B, you are talking about the same thing. The chance that A and B both happen. P, A, inverted N, B. The symbol N or inverted U is read as intersection. So you read that one as P, A intersection B, which means A and B both happen. It comes from set theory, where the intersection is the overlap of two sets. So P, A, and B, in brackets, this is just a plain language version of the same idea, P intersection B. It says directly the probability that A and B happen together. So P A intersection B is equal to P A and B in brackets. Both represent the same probability, the chance that both events A and B occur at the same time. Guys, it is raining, so I have to raise my voice. This evening it's raining. It's a rain season. The two notations. Example, let's say event A equals getting hands when you toss a coin. Implies PA is equal to half. Event B equals rolling a 4 on a die. Implies probability of B is 1/6. Since they are independent events, the probability of A intersection B is equal to PA, or probability of A times the probability of B, which is 1/2 times 1/6, which is 1/12. You could also write this as P, A, and B in brackets is equal to 1/12. Both are correct. The only difference is the notation, not the meaning. One is once, the other one is a symbol. The two forms of probability formula. Non-mutually exclusive events. At least one of the events A or B or both occurs. Symbol form. P, A union B in brackets is equal to PA plus PB minus PA intersection B. One form. P, A or B is equal to PA plus PB minus PA and B. Because A and B means intersection. The one and means intersection. Then we come to independent events. Guys, sorry for pronunciations. That is, both events A and B occur simultaneously. Symbol form. P, A intersection B is equal to PA times PB. One form. P, A and B, where and represents intersection, is equal to PA times PB. You see, those formulae are the same. Let's look at the meaning of the symbols. U, meaning of the one is all. Meaning in ones. The U meaning in ones is all. How to read it is A or B or both. The inverted U meaning in ones is and. And how to read it is A and B together. So P, A union B means the probability that A or B or both happen, and P, A intersection B means the probability that both A and B happen together. Remember, guys, we are repeating this so that when you do this, probability will be very easy. Clarifying the formula, and we start with formula number 1, which is P, A union B is equal to PA plus PB minus PA intersection B. When to use? General case, A and B can occur together. A and B are not mutually exclusive, meaning you are calculating the probability that either A or B or both happen. You subtract P, A intersection B to avoid double counting the overlap. Example, let A equal to student passes mathematics and B is equal to student passes English. Some students pass both, so P passes maths or English is equal to P maths plus P English minus P both. Let's come to the second formula. P union B is equal to PA plus PB, where you don't have the subtraction. A and B cannot happen at the same time. That is when to use it. A and B are mutually exclusive, meaning you are calculating the probability that either A or B happens, but not both. No overlap exists, so no need to subtract, meaning you are calculating the probability that either A or B happens, but not both. I think I've repeated that one. No overlap exists, so no need to subtract. I'm trying to expound. Example, let A is equal to student scores grade A and B equals to student scores grade B. A student cannot score both grades at once in a single subject. So, P grade A or grade B is equal to P grade A plus P grade B. So we have the summary table where we have the formula, use case, type of events, why it works. Therefore, we have P union B is equal to P A plus P B minus P A intersection B. Use case is events may overlap. Type of events are not mutually exclusive, and why it works removes double counting. And then P A union B is equal to PA plus PB. Events cannot overlap. These are mutually exclusive. And how it works, no overlap to subtract. So when events overlap and when they stand apart, we have got two diagrams here, what we call Venn diagrams. Venn diagrams are circles. You just represent them with circles. So if you look at the left, you have the event A and B, where you have the two circles intersecting. All right? The intersection is what is common in both A and B. And that is what is subtracted to get the probability. PA union B is equal to PA plus PB minus PA intersection B. Then the second one is where they are separate, because there is no overlap. So PA union B is equal to the probability of A plus the probability of B. You don't subtract here because there is no overlap. So here I will read for you. The letter W is not there, and the letter H. So when events overlap, we subtract the shared. When they stand apart, we simply add. Let me repeat. When events overlap, we subtract the shared. When they stand apart, we simply add. So we have another summary table, the formula, the Venn diagram, event type, why it works. So P union B is equal to PA plus PB minus P intersection A intersection B. Venn diagram, overlapping circles. Event type is not mutually exclusive. Why it works? Correct double counting. Formula, PA union B is equal to PA or probability of A plus probability of B. Venn diagram, separate circles. Event type is mutually exclusive. Why it works? No overlap to subtract. Now, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Or P, A or B, the one form equals PA plus PB minus PA and B. Why the formula has a minus sign? If we simply added PA plus PB, we would be double counting the overlap. Can you get that, guys? because there are some members who are in A and others are in B. The situation where both A and B occur. So we subtract P, A intersection B to correct that. Example, to make it clear. Event A, getting a red card. There are 26 out of 52 red cards, and the probability of getting a red card is 26 over 52, which is a half. Event B, getting a king. There are 4 kings out of 52, and therefore the probability of getting a king is 4 over 52. Simplify and you get 1 over 13. So overlap is A intersection B, red kings, that is 2 out of 52. And therefore, P probability of A intersection B is 2 over 52, which is 1 over 26. Now, P A union B will then be equal to 1 over half the probability of a red card plus 1 over 13, the probability of getting a king, minus 1 over 26, the 2 red kings which are being repeated in the kings there, and you get 1 over 26, which is equal to 8 over 13 when you simplify. So here, I am displaying the coins, that is tossing a coin and rolling a die. I'm trying to show the viewers how a coin looks like with the head and the tail. For example, this one is the coin of the first president of the Republic of Kenya, Mzee Jomo Kenyatta. That is his head. And the tail is the other side where we have got what you call it? Republic of Kenya, 1 shilling, coat of arms, sorry. It is called coat of arms. So the head of the president is the head, and the tail is the coat of arms. On the other side, we have a die, which is unbiased die. That is when you throw it up, it can land on any side. And we are showing that we are showing the side which is 1, 2, 3, 4, 5. And you can also see the side which is 1, 2, 3, and the side which is 1, 2, 3, 4. So we have 3, 4, and 5. So you can see the other sides are 1, 2, and 6. Independent events. We are looking at the type of events. We start with independent events. The definition, what is an independent event? 2 events are independent if the occurrence of one does not affect the probability of the other occurring. In other words, knowing that one event happens gives no information about whether the other happened. A and B can occur together. One happening does not change the chance of the other. For example, tossing a coin and rolling a die. Event A, getting a head on the coin, and event B, getting a 4 on the die. These are independent because what happens on the coin does not affect what number appears on the die. That's why they are independent. Implies what you roll doesn't affect what you toss. So A and B are independent. They occur independently. Mathematically, connected simple is the inverted U or N. You can call it N, and it means and, because both A and B happen together. That is, the probability of both events happening equals product of their individual probabilities. That is, probability of A intersection B is equal to probability of A times probability of B. Type of events number 2 is mutually exclusive events. Definition. Two events are mutually exclusive or disjoint if they cannot happen at the same time. If one event occurs, the other must not occur. No overlap exists. That is, the probability of A intersection B is equal to 0. P, A intersection B is equal to 0. In other words, if one occurs, the other cannot. Their outcomes are separate. For example, A represents getting ahead on a coin, and B represents getting a tail on the same toss. This implies you cannot get both on one toss. These are mutually exclusive because both cannot occur in the same toss. Mathematically, the formula is P A union B is equal to PA plus BB. No need to subtract anything because there is no intersection. No overlap exists. And finally, in type of events, we have the third type, mutually overlapping or inclusive events. Definition. Two events are mutually overlapping or mutually inclusive if they can occur together, meaning they share some common outcomes. The probability of A intersection B is not equal to 0. There are some members who are doing the common event. In other words, the events overlap. They are not mutually exclusive because both can happen at once. For example, A represents students who play football and B represents students who play basketball. This implies some students take both games. That is the overlap. Some play both, so P A intersection B exists. Connected formula, P A union B is equal to PA plus PB minus PA. We subtract the intersection once because it's counted twice in PA and PB. Memory tip. Think of inclusive as including each other. Both can happen together. Conclusion. Now, you know the basic probability rules. That is addition, multiplication, and complement. Try applying them in real-life examples around you, from weather forecasts to games of chance. Don't forget to like, share, and subscribe for more simple maths lessons from smart_traveler Memoirs. See you in the next class. Quick memory cues. Independent implies no influence. Inclusive implies they overlap.